Thank you. For the last 9 years, we've underestimated the impact of a whole class of vulnerabilities in PHP. Hundreds, probably thousands of instances of this issue have been found, and a simple behavior in PHP exposes them to exploitation through unserialization. My name's Sam, and I spend a lot of my time attacking web applications. And so I always ask myself, what vulnerabilities does this app have, and what can you do with the vulnerabilities? And the research I'm going to talk about today doesn't really affect the first part of that question, so I won't be introducing any new types of vulnerabilities, but I'll be demonstrating a new exploitation technique which should hopefully give you guys a surprising answer to the second part of the question, what can you do with certain vulnerabilities? Before I introduce my own research, I think it's important to say that this is really just a tiny addition to some wonderful research done by Stefan Esser almost 10 years ago. He discovered this unserialization vulnerability and came up with a really unique way to exploit it. So I'm not going to go into a lot of detail about serialization and unserialization, but really briefly for anyone who doesn't know what it is. It's a process by which internal objects in PHP are converted into a string representation, which can be passed over the wire or stored in a database. And then unserialization can convert that representation back into an instance of the object. Now, obviously, the examples on the slide are really simple, so there's an integer and a string, but it can represent far more complicated objects. And what Stefan Esser realized was that you can use this technique called property-orientated programming, which is very similar to return-orientated programming in sort of native code, to reuse certain bits of code which are already loaded or accessible to the application and chain them together to cause some malicious action to occur. And to me, his research was years ahead of its time. So if we look at the corresponding issue in Java, people sort of started talking about it in about 2011. And it wasn't until a couple of years ago when Chris Frohoff released the tool Unserialization that we really started to see widespread exploitation. Whereas the issue as Stefan Esser introduced it in PHP already came with sort of example payloads in widely deployed libraries and was essentially fully formed in his original work. So the details here are essentially how the issue is exploited. So when the target application unserializes the malicious serialized object that we've given it, this will cause certain what PHP calls magic methods to execute. So there's one called __wakeup, which will occur whenever an object's unserialized. And also there's a garbage collector, which will cause the method destruct to execute. In the conventional unserialization issue, something is going to be done with that data. So the application has deliberately unserialized something and is expecting a certain type of data. So it's also quite easy to trigger magic methods like toString or other similar things to that. Essentially, at this point, if you don't know anything about unserialization, I just need you to accept that it's really bad to unserialize attacker-controlled data. So this is the agenda for the talk. And the first thing I'm going to discuss is something called stream wrappers. And we'll focus on a specific stream wrapper called the FAR stream wrapper. We'll look at the file format. Well, a FAR is a type of archive, so it's supposed to be the PHP equivalent to the Java archive. And we'll look at the file format for a FAR archive. We'll look at something I've called FAR planting, so that's getting a FAR archive onto your target, looking at any methods that might work beyond simply uploading a file, identifying the type of vulnerabilities that are affected by this. There's a tool called PHP GGC, which is essentially the PHP equivalent of Why So Serial. And the author's kindly given me permission to release a branch alongside this talk, which implements the techniques I'll be talking about. But it uses the same payloads which are already there, but can encapsulate them in this FAR file format. The second half of the presentation is largely looking at some real-world case studies. I'll talk briefly about how we might defend against this issue and a few things I'd like you to take away from the talk. So Largely the first part of this talk is just going through stuff in the PHP manual to explain how I found out the behavior that I mentioned earlier. And I found this XKCD comic, which I thought was particularly apt. If it doesn't make a lot of sense now, hopefully when I've shown you a few sections of the manual, you'll begin to see why. So this is stream wrappers as they're defined in the PHP manual. And essentially they're an interesting feature which causes certain complex functionality to kick in from any file operation. So they should be quite familiar to anyone who's done sort of exploit development or web app testing before, because they're used in lots of different types of vulnerabilities. So these are all the stream wrappers which are enabled in PHP by default. And I've sort of grouped 4 of them as the remote stream wrappers. So provided this PHP any setting allow URLf open is true, then we can access remote files as if they're local files, simply by supplying, for instance, a HTTP path or an FTP path. I've put data into that group, although it's not strictly remote. Obviously, you would include the data that you wanted to use in the URL, but it also requires this setting to be true. So a simple example of where that's used in exploitation is turning a local file include into a remote file include. Now there's another PHP any setting which actually controls whether that works. You also need allow URL include, I think, to be set to true. But this is also, sort of this behavior is what makes a large number of server-side request forgery issues exist. So if we have control of the variable that's used in a call to file get contents and we give it an HTTP path or an FTP path, then it will go off and remotely retrieve something, and obviously that could be an issue. And it's the same behavior that's used for any external communication from an XXE issue. The next interesting stream wrapper is the PHP stream wrapper. One way this has been used in a number of exploits is if we have PHP : / input, that kind of grabs standard IO and treats it as if it's a file. So if we're in a web server, web application scenario, that's generally what you've posted to the page, but it will be treated as if it's a file. If you have a local file include issue and you want to read the source code of a file, obviously if you try to include a PHP file, that will be executed. But this stream wrapper has this interesting feature called filters. So we could base64 encode a file before it's included and then decode that on our end and read the source code from a file. Stefanessa made a really clever use of this filter feature in a certain scenario in one of his first unserialization exploits. So he managed to put together a gadget chain which resulted in writing some data to a file, but this was prefixed with this sort of PHP die command, which would prevent anything after that from running. But if we simply base64 decode what's being written to the file, then that would sort of nullify this sequence and he could execute code. The next stream wrapper, there's one called glob, which whenever I'm looking through these, I think is going to be really useful and sort of allow you to get directory listings. But it doesn't work the same as the others, so you can't file get contents on a glob URL and get a listing of files. This is the example they give in the manual. So they use a directory iterator with a glob URL or URI. And similarly, each stream wrapper kind of has a list of what features it supports, and glob literally supports none of them. Okay, so then there's 2 stream wrappers left, which these are, of the ones enabled by default, and one is zlib and one is far, and these are both for dealing with archive files. And so looking at them, very briefly, they look like they'll be quite boring. Maybe there'll be some issues with the native code, and we can sort of give a corrupted archive or a maliciously constructed archive and try to hijack the system that way. Exploiting an issue like that's likely to be quite difficult in the presence of modern mitigations, sort of ASLR and DEP and things like that. Obviously, I wouldn't be giving this talk if we finished there. So what happened is I had a more detailed look at this file wrapper because I'd never heard of the file format before, what's actually in a file archive. So immediately upon looking at the elements of the archive, and again, this is another excerpt from the manual, The first thing they list as in an archive is called a stub. And a stub contains PHP code, which, anyone doing offensive security, that immediately looks interesting. I'd love to say that the stuff I'm going to talk about today, I sort of did some complex code analysis and found the issue. But to be honest, I read the manual and tried some silly stuff, and one silly thing worked. So the first silly thing I tried was to write a simple test program to generate one of these archives with the stub set to some code to just echo out something if the stub was running. And then tried accessing a file within that archive through the stream wrapper. And unsurprisingly, the stub doesn't execute. And just to sort of confirm everything was working right, I executed that archive and the stub indeed gets executed. And as far as I can tell, that's actually the only way to activate the stub. So you would need one of these far files to be executed, which would mean essentially, if I could execute a far file, I could probably execute a PHP file, so it's not buying me anything. But not wanting to be deterred, we look at the next element in all far files, and it has something called a manifest. And there's another page in the manual which lists what's in a manifest. And there was one thing which immediately grabbed my attention. So a manifest can contain serialized metadata, which is serialized in the standard PHP form. So again, I tried something stupid. I wrote a simple test program which defines a class called test object and sets the metadata to an instance of this class. Then I wrote another test program which defines this class again, but this time includes a destructor, so that if this object is unserialized and then destroyed, we would see the destructor get executed. And so I tried my silly test program, and much to my surprise, it actually worked. And I guess if I hadn't told you all this was coming, you'd probably go something like this. So sort of to confirm everything was working how I expected, I tried changing a couple of things. So I wrote another test program. Instead of grabbing the contents of a file, let's just check if that file exists. Now, to me, this seems like probably the least significant file operation, or you would think the least risky as a developer. Like the worst thing that's going to happen is someone can figure out if a local file exists or not. Similarly, we can change the path after the name of the archive to just some gibberish to see what it will say to a file that clearly doesn't exist. And in both cases, the destructor runs again. And so hopefully that cartoon now makes a little bit more sense. So sort of from this information, a really obvious approach to an attack emerges. There'll be two steps. If we can get one of these archives onto the target and then trigger some operation with the stream wrapper upon it, we can unserialize sort of an arbitrary payload. This is quite similar to local file include. And indeed, later I'll sort of talk about some of the inspiration we can take from different ways people have come up with for exploiting local file include. For people who are more familiar with the traditional issue, these are kind of a couple of small things I'd bear in mind when we're exploiting this issue. So I kind of hinted at it earlier. When this happens, the application has had no intention to unserialize our data, so it's not going to do anything with it. It just sits there. So the only sort of payloads which we can use have to either be started by wake up or destruct. And there's this unusual behavior with the destruct chains that for whatever reason, the object is garbage collected. I think probably after the rest of the application has run, but for some reason it sort of lost the context of the application. So any file operations that we do in that chain have to use absolute parse. And the final element, well, no, sorry, I've skipped an element, that the file contents are the file contents. But also there's a signature, which it says is optional. But again, this is a PHP ini setting, which by default is set so that we need a signature. So as an attacker, that's not optional for us. Hopefully by this point you've got bored of the manual and will trust me if I tell you a few more details about the file. So there's three valid file formats for FAR archives. There's this sort of base FAR format, there's a tar version of the format and a zip version of the format. For the rest of the talk, I'm going to ignore the zip format. It could be useful if we're targeting an application which has some legitimate functionality which allows us to upload a zip file. But the other two offer some interesting flexibility that I wanted to talk about. So the first one we'll start with is the base file format. And I've done sort of a hex dump of one of those test files that I generated with these test programs, and we can see the different elements highlighted of a file archive. So in terms of unserialization, the green bit here is the serialized data in the standard PHP form. But what I sort of really want you to notice from this is the stub. Although the stub's no use for running code, it's the first thing in the archive, and we can put anything in there as long as we have this small piece of PHP code. So we can prefix this with anything we want, and it will still be a valid file archive, provided that we calculate the signature and everything like that. So I think this is saying essentially the same as I just said. So we can make a pretty good fake of any file format by putting data in front of a file archive. One important detail is that we literally can't put anything after it. So the signature was the last thing in the archive. And literally any single byte after that GB will cause it to no longer be a valid archive. So there's some circumstances in which flexibility elsewhere would be useful to us. And tar is quite a complicated file format. I'm not going to go into the full details of tar, but these are the details that are interesting to us in terms of this attack. And essentially, particularly these two details. So the first 100 bytes of a sort of tar encapsulated file archive, and indeed any tar file, are the file name of the first file. So there's no reason we shouldn't be able to change that. And the end of the archive is marked by 1024 null bytes. And critically, everything after this is ignored. So what we can do is take this is a simple sort of test archive that I generated, and I can change the file name provided that I fix up the checksum. And I'm going to explain to you what I've changed that file name to. So the first 2 bytes are a JPEG header. The second 2 bytes are saying this is a comment. And the next 2 bytes are the length of that comment. Now I've set the length so it encapsulates the whole archive, including the 1024 0 bytes at the end. And then we can simply carry on the JPEG file and be both a valid file/tar archive and a valid JPEG. So I'm just going to sort of quickly try and demonstrate that with a picture. So on my desktop, I've got a picture of my cat. But if I change the file name of this picture, I can, Wimra wants to tell me something. Hey, advert. So it's got this unusually named file in it, but it's also got all the elements which make up a file archive. So it's got the stub, and it's got the metadata, which is in the standard PHP serialized format, and it's got the signature, which isn't really sort of readable, but. So that file is, a perfect polyglot. It's both a valid JPEG and a valid archive. Okay, so I mentioned sort of thinking about other ways we might get one of these files onto the target if we can't just upload it. We can look at a few tricks people have developed for local file includes. So Brett Moore came up with this technique using PHP info, where if you post anything to a PHP file, so if you post a file to a PHP page, it will save a copy of that file in the temporary directory and populate the $_files variable. And PHP info gives you a dump of this file. But once PHP info is finished running, that file will be deleted. But what you can do is essentially sort of stall PHP info from returning everything, and that file sits there and you've got the name of it. And similarly, a guy called Jimmy Ramsmark demonstrated that the entropy basically isn't very good in Windows in particular with its temporary file, so it's not that difficult to brute force the name of a temporary file. If we have some primitive like the one shown on the slide where we can completely control a session variable, then we can do something very similar to what I showed with the JPEG. Provided we're within the first 100 bytes, we can cause the session file to both be the valid session file and a valid archive, and then reference that through the stream wrapper. There's a couple of other ones I've listed there which are things I haven't managed to pull off, but I suspect are possible. So on some architectures, proc self, all the file, well, the things that look like files to PHP within proc self will be populated with different things. So proc self environ sometimes gets the user agent and things like that. And log files should be exploitable, but it's quite tricky. So if we were going to use the base file format, we'd need to be writing right to the very last byte of the log file. Even a new line would break our archive. If we went to do the tar trick, we're going to need to write an awful lot of null bytes to a log file, which might not be possible. And in both cases, we need to know the entire contents of the file to have valid signatures. Okay, so in terms of identifying vulnerabilities, like I mentioned, we're not really talking about any new types of vulnerability. It's exploiting what are essentially XXE issues or server-side request forgery. So the one interesting aspect with XXE, well, both of them essentially, is that you don't need any outbound connectivity, and you can even, specifically, there's a libxml option which disables network connectivity, but far is a local file, is all to do with local files, so it won't prevent you using the far stream wrapper. FTP stream wrapper is far better than the HTTP one for detecting this issue because it supports many more operations. So if you call file exists on a HTTP URL, that will do nothing and just return false. But if you call file exists with an FTP URL, it will go out and connect to the FTP server. And I'll demonstrate that with one of the issues to see, it's quite an easy way to try and detect these issues in a black box scenario. If we've got no out-of-band communication, so either allow URLF open is set to false, or there's no path to our system either directly or through DNS, then we can sometimes look at how the file stream wrapper behaves. So if that works, then it's likely that we're triggering stream wrappers. So PHP GGC, which I mentioned earlier, is essentially the PHP equivalent of YSO Serial. So it's a tool for generating payloads, which has sort of almost like a database of known payloads within it. It's developed by a guy called Charles Foll, and he kindly gave me permission to branch it. So what I've done is just added a really simple tool onto it called FAR GGC, which allows you to put these payloads into a FAR using one of the two techniques I mentioned earlier. There's this PHP ini setting, which we need to set on our local system to actually be able to write to FAR archives, because we let PHP do all the work in terms of generating the archive file. I've made a slight change to the payloads that are included with it at the moment, because most of them no longer work with PHP 7.2. As a defense in-depth mechanism, they sort of got rid of something that people used to often use in exploits, which is they limit what functions you can call dynamically. So for instance, you can't call eval or include, but for a long time they left it so you could dynamically call assert with a string and that code would get evaluated, but that doesn't happen anymore. As a sort of quick fix, I've changed everything to use pass-through, which runs a system command and spits out the output. On some sort of lockdown systems, commands like pass-through or exit or other sort of commands which execute system commands will have been sort of locked down and prevented from running. It seems to me that nearly every large application now uses a library manager called Composer, and that includes a simple wrapper for include, so suddenly we can dynamically call include. So if we're in that scenario where we want to run PHP code because we can't sort of run one simple command to do what we want to do, we can consider calling this function. As I mentioned, if we're in a destruct chain, we'll have to use absolute pass. So what we might do is start off by including etc password, and as long as that works, we can start trying to brute force the name of either some file we've uploaded, or if we want to look clever, we could include the code into the FAR archive and grab it from there. Okay, so there's a bunch of case studies I'm going to go through, and with all of them, I found the issue through manual code analysis. Two of them could have really easily been found just by using the FTP wrapper. One of them is a little bit more subtle, and it might be a bit boring, but all of them are sort of in scenarios where I can just upload a file onto the target. So the first one is a CMS called Typo3. They've fixed this issue in the most recent version. It's the only issue I'm going to look at today that's actually been fixed. And many thanks to a guy called Oliver Hayder, who basically looked after fixing it. And they've done quite an interesting thing as well. They've created their own custom file stream, as well as sort of fixing the underlying issue, which I identified, which allowed you to activate the stream wrappers. They've written a custom file wrapper to prevent the system one from being abused in any scenario. So the path from user data to the vulnerability is reasonably complicated, but the actual issue is fairly straightforward. So what happens when it's processing links sort of internally, it tries to figure out what sort of file it's looking at. And the problem here is that after it's done all these checks, it URL decodes the value. So provided that we encode any colons, it's not going to see something as as being a URI with a scheme. It's going to assume it's a local file and call file exists on it. So by encoding, we can cause it to activate the stream wrappers. So let's have a quick look at the demo. So the first thing we need to do is generate a payload. Like any sensible person, I've got a bunch of pictures of cats in my pictures directory. What I'll do first, so this will list the payloads available in PHP GGC. Some of them use toString as the starting point, so they're no good for us, but all the ones that use destruct or wake up, we can use with this technique. So what I'm going to do is generate a payload. So I'm going to use cat1 as the input. I'll output it as typo3. I will use guzzle/RCE1 as the payload. And I'm going to try and run uname-a on the target. So that's been written to typo3.jpg in my pictures directory. I'm going to exploit the issue as admin, which might seem a bit weird, but so this CMS sort of implements a fine-grained access model. There's no standard roles and stuff set up. So the functionality we're abusing is certainly not only available to admins. So the first thing we need to do is simply upload that file. Whoever's doing the other presentation is much funnier than I am. Right, so we just upload, we're in a scenario where we're able to upload files into the application that appears as a JPEG. So I'm going to go to any page and I'm going to add some content. And I'm going to add an images only element, which has a link property down here. So actually what I'll do, if I set up a listener on another server, that's the P, isn't it? Right, so that's listening on port 443. And provided that I encode the colons and don't have stubby fingers, colon 443. Now, if I've got this right, when I save this, I've clearly got it wrong because that didn't. I've lost track of my IPs. This is one of them. Yeah, right. Apologies. So the server I'm attacking is .100 and I want it to contact .101. When I save that, this time it has connected to us, and if I pretend to be an FTP server, that'll probably do. It's basically looking for the file in the URL that we gave it. So we can see that stream wrappers are definitely activated there. Now if I go to my notes and get the file path, and I'm just going to intercept the request. Now intercept the response to this request, and hopefully at the top of it is run uname -a. So that's essentially the exploit working. Woo. Okay, the next example is in WordPress, and when I first discovered this issue, I sort of wanted to find an instance in a fairly high-profile app, and thought, you know, WordPress was a good target, and I assumed they would fix it fairly quickly, and I could move on and find some other examples and do a presentation. But they still haven't fixed it at this point, and you know, understanding this issue obviously affects lots of applications, so it's difficult to try to wait to talk about it because there's one instance in an app, and I felt it had got to the point where it was irresponsible not to disclose, if that makes sense. So this is my favorite vulnerability because it's more subtle than the others. The vulnerability is in some legacy functionality for dealing with thumbnails, and the problem is in the highlighted code. So it calculates a variable called thumb file and then calls file exists on it. And it calculates the value of this variable by replacing within file the base name of file with something. Now there's a bad assumption there, which is that the base name of the file only occurs in the place where the base name is. So we can completely control this value image data thumb, and we can partially control the value of file. So file comes from get attached file. I'll point to them over there. So get attached file. So if we look at the code from get attached file, in most circumstances it prepends the application's upload path. But there's certain circumstances in which it doesn't. So if the value of file starts with a slash, then it's an absolute Linux path, and it doesn't bother prepending it, but that's no use to us. But if the file starts with something that looks like an absolute Windows path, so a single character followed by : then it also doesn't prepend this value. Now, despite the fact we're attacking a Linux system, we can set this value to something that looks like a Windows path. In terms of the payload that we use to exploit this, so until WordPress 4.9, there was a publicly known payload to go from toString to code execution. And we'd simply basically add something to trigger a toString from a destruct. But that doesn't work anymore, so we have to go looking for a new payload. And WordPress is one of the few PHP applications that doesn't have an autoloader, so you're limited to the classes which are already loaded by the application. And this is one of the few classes that looks particularly interesting. So they've got this class called request utility FilteredIterator, which is an array iterator. So you can basically set this as the iterator of an array, and if you iterate through that array, this code is triggered, and this code calls a function which is defined by a property. So provided we can trigger something to go through this array, then we can execute arbitrary code. I looked around within system classes and any of the few classes that were already loaded, and I couldn't find something to do that. So the sort of next natural thing to do is to go and look at popular plugins. WooCommerce, which is commonly, it's a very common e-commerce setup to use WordPress and WooCommerce together, has a destructor which runs through a bunch of handles, and it's supposed to just check if something's a resource and close the file, but all we're really interested in is the fact that it runs for each. So let's have a look at that demo. For this demo, I've scripted most of it because I'm sure I would forget something and mess it up. What I'm actually going to do first, provided WordPress seems to run horribly slowly. Is that working at all? So what I was going to do here, and I may abandon, was just load up WordPress and show you what user I'll be exploiting it as. So it has quite well, by default, it has a far simpler sort of privilege model. And you have in WordPress, you have unauthenticated, subscriber, author, editor, admin. And we can exploit this issue as an author. So I've got a user set up called author to exploit it. Now, given that this isn't loading, there's a good chance it's not going to work, but I'll give it a try. Thank you. I always keep doing that. That's the problem, isn't it? Ta-da! That's my favorite way to fail. Right. So this is the latest version of WordPress and has the latest version of WooCommerce installed as a plugin. But we're going to be exploiting is this author user who has the role author. And now I actually want intercept on. Onto my desktop. So this runs through quite a few requests to set the various elements that we need to. And the first thing it does is an XML RPC call to upload a file. So doing it via XML RPC means it uploads the value in the request is base64 encoded, but we can have a quick look at what that looks like. So this basically is a standard file format archive, but it just has a few bytes in front of the stub that makes it look a tiny bit like a PHP file. Now, so it's uploaded the file. The next thing it does is log into the into the application through the web interface because we need to grab a cookie. So it does that. We'll be grabbing the cookie for access to the backend. Once it's got that cookie, it's going to access the URL to edit the post, which corresponds to the media item that we just uploaded. And it needs to do this to get a nonce to do something else. So if we intercept the response to that, somewhere in here. So it's grabbing this nonce, which is a hidden value in a form, so it can set the file value and the thumb value to what it wants. So this one is setting the file name to z:/z. So that's going to cause, when that replacement of the base name happens, it's also going to replace the very start of the file name, which allows us to trigger the stream wrapper. And then it's setting the value of thumb to this far path. Now, I mentioned that in the payload we can't use relative paths, but you'll see here, when we're triggering the issue, we can find the relative path on our local system, and this is will be a valid attack on any system because we're simply using a single dot, so just the current directory and then WP content and where we've uploaded the file. So now we've set all those values. When we call this XML RPC method, get media item, it should do something interesting. So at the very end of this, you'll see that I've run ls-l. Sort of very quickly. This is the script, and we could just change that to anything. So it uploads the file and triggers the stuff and runs the command. Right. Okay, so the final case study is in a library called TCPDF, which seems to be the standard library to convert HTML to a PDF in PHP. So loads of applications use this. It's sort of developed by one guy who's been really helpful, and I think he's depreciated it and he's coming out with a new library, but I think he's going to fix this hopefully very soon and release a new version. So as I mentioned, it's a very common library to render into a PDF. So it can be exposed either deliberately when, by design we can edit the HTML that's going to be put into a PDF, but often in testing we find scenarios where you can cross-site script into some HTML that's being sent to a PDF, and that's a very common scenario for server-side request forgery. So the vulnerability here is really simple. The library has a HTML tag handler, and if it encounters an image tag, it calls this other function image. And this does various stuff, but eventually falls through to calling file exists on the path that's been supplied. So let's have a look at the demo for that. So again, I need to generate a payload, obviously using a different picture of a cat. We'll run cat etc password. Similar to Typo 3, this is quite a complex CMS that has fine-grained access controls. And the point here is really that the vulnerability is in the library, not in the CMS, but the CMS is a nice, easy way to sort of trigger it. So again, the first thing we need to do is just upload the payload which we generated. And again, the application just sees this as if it's an image. And I've already got within the application an article set up. In fact, we'll open this. So at the moment, the article just has XXXYYY in it. And I've got this setting here, export as PDF enabled. So that's an option for this article, which will send it straight to the library. So if I edit the contents of this article, so I'm going to chuck an image tag into the middle of the, if I press the right button. At the moment, I haven't put the stream wrapper on that image tag. I was just going to show you how it behaves with just a pointer to that image. So there's no image as far as the browser is concerned at that path, but the PDF renderer deals with it slightly differently. And so we'll get a PDF with just the picture in as a picture. But if I tell it to try to access something within that as an archive, now the browser doesn't even display a broken image tag because it doesn't like sort of the scheme of FAR. It's obviously not something the browser knows what to do with. But once we tell it to generate a PDF, it triggers the code. And that's the demo's gone through, and thanks to the person who told me Interceptor was on, they all worked. Right, in terms of defending against this issue, obviously we'd love to avoid it altogether by not having the vulnerability, but bear in mind that it's XXE or server-side request forgery looking things. Obviously these are found all the time. Certainly should be easy to sort of detect in a signature-based way. So IDSs or IPSs should be easily able to pick up the fact that we've got a nasty payload in an archive or a polyglot. You can't disable the stream wrapper from the command line, as far as I can tell, or from any settings. But if you really urgently decided you needed to disable this, you could probably look at doing it during compilation. I did let PHP know about this a couple of months ago, and I haven't heard back, but I'm hoping in the long term that they'll obviously change the behavior, because there isn't really any reason to unserialize that data at that point. It's a feature that's supposed to be there, that you can have metadata in these archives, but there's no reason to unserialize it until someone specifically requests it, rather than just accessing the archive through the stream wrapper. Okay, what do I want you to take away? So more broadly than just this issue, I think there's a deeper issue in PHP and other languages, that basically applications are getting more and more complex, and we're not paying any attention to what code is included. We're leaving stuff in that's no longer used. This library manager called Composer seems to be the standard now in PHP, and that lets you, through unserialization, load any class included in the application. By abusing the stream wrapper in a few different vulnerability scenarios, we can trigger this behavior. Some of the vulnerabilities that we can get code execution from would have been considered extremely minor, especially if allow URLF open was set to off. They might have disclosed to you that a local file exists, was what people would have imagined the worst that could happen. And it's fairly easy to find these issues either through black box techniques or code analysis.